This video is for lesson 10.3. So there is no Spark today, so we're going to go ahead and just jump in. So lesson 10.3 wants us to identify patterns in tables and graphs, and then we're going to use those patterns to write ourselves equations. So we will know that we can do that when we can identify the pattern, then use it to write an equation. So if you, at the end of this, feel like you can find a pattern and write an equation, then you are doing grade level work at a 3. If you feel like you can identify the pattern from the table or the graph, you can write an equation, solve an equation, and explain it. That is above a 4. If you can solve the equation once it's been given to you, that's a 2. And if you can solve the equation with help, that is a 1. So we're looking to be here today. We want to identify the pattern and then write an equation with that information. So number 1 tells us to use this table below to complete each statement. So we are looking for patterns here. So before we even get into the task, let's just go ahead and see what kind of patterns we notice. Let's go ahead and cover that up so it's not distracting us over here. So I notice X here is 2 and here is 10. I always like to look for numbers that look compatible and easy for me to figure out. So one way I know I can get from 2 to 10 is 2 times by 5. But if I know that I come down here and do it on this one, 7 times 5 is not 15. So I don't think that the pattern is to times by 5 every time. So let's see if we can find another way to get from 2 to 10. So to get from 2 to 10, we can add 8. So let's see if I'm at 3.25 and I add on 8, 3 plus 8 is 11.25. 4 plus 8 should be 12 and a half. 5 plus 8 is 13.75. And 7 plus 8 is 15. So it looks like this pattern every time is that we're taking X, we're adding on 8, and it equals 11. So we take this pattern and just come plug it into your variables here. We have X, add 8 more, that equals 11. So let's see if we can, I'm giving you some answers here. I forgot to cover those up. So every time, there's also patterns that sometimes go up and down depending on how the chart was filled out. So I know we've seen charts that don't go in order. This one happens to go in order. So every time X grew or increased from 2 to 3.25 is 1.25. So every time X went up by 1.25, Y also went up by 1.25. So adding on $1.25, adding on $1.25. So that pattern goes down. So each time they're going down, we're adding on $1.25. Each time we go down Y, they're also adding on. So we have patterns that can go down the X column, down the Y column, and they can go across. So we've already answered. How did we get from X to Y? Well, we know we added on 8. So each value, I swear I had these covered up. I must have erased that. So each value of Y is 8 units bigger than X. So we have to add on 8 to X. So this, to me, right, this sounds a little backwards, but if we think about it, Y is 8 more than X. Y is 8 more than X. We have to take X, add on 8 more, equals Y. So X is 8 units smaller than Y. Y is 8 units bigger. So we've already written this equation as we notice this pattern. We noticed every time they added 8. What did they add 8 to? To any of these, which are represented by X. What will it equal? Any of these, which is represented by Y. So we could put any number in here. I could say that I have 10. I'm adding on 8, and that would equal 18. And you can also check yourself with one of the problems that has been given. 2 plus 8 is 10, 2 and 10. So that one works there. So go ahead and complete task 1 and come back. Well, actually one thing. So I noticed in task 1, it kind of had some new words here. So as we were noticing these patterns, so to get from Y to X, we were adding. To get there, we added. So that means anytime you're adding or subtracting, since those are equivalent operations, they're the same thing, we're going to call those additive. You can hear that word add in there. So even if we subtract, we still call it an additive because we can rewrite that equation and make it an addition problem. So the value of Y, and now you should be able to finish the rest of that. So if we're multiplying or dividing, that's when we call it a multiplicative in operation. And if we have exponents, it's exponential. So multiply and divide are equivalent. We do the same thing back and forth. Additive, add and subtract, and then exponents here. So I just noticed that was a new word for us. When we're adding or subtracting, we call that additive. So go ahead and complete task 1 and then come back when you are ready to do task 2. Task 2 tells us that Mara is making bracelets for every red bead. So every one time she uses a red bead, she uses 4 green beads. So you can kind of see that here, right? 1 red bead and then 1, 2, 3, 4. 1 red bead, 1, 2, 3, 4 green beads. So it's following that pattern to wrap around. So the graph below represents this situation. So on the bottom, we have red, and going up the side, we have green. So X is red, green is Y. So we want to use 1 red bead and 4 green beads. Now, I notice these are not counting by the same scale. Here, every mark counts for a half of a bead. So we've got to go over 2 to get to a full bead. And when they're going up the Y scale, they're counting by 2, 4, 6, 8. So notice and pay attention to that. So we want to complete this chart. So this first one is over 1. We always go over first to get to our elevator. Then our elevator can take us up. So over 1, up 4. So X is 1, Y is 4. So I'll do one more with you. Over 2, and then I went up 8. So over 2, up 8. So see if you can finish this graph in part A and then come back. So our next part asks us to notice patterns that we see. So every time X increases, so I notice, right, every time we're using 1 red bead, Y is increasing by how much? Y is increasing by 4, 8, 12, 16. And this is only jumping up 1, 2, 3, 4. So each value of Y is blank the value of X. So this first one asked us, how do X and Y grow? Now it asks, how do we get from X to Y? So to get from 1 to 4, this is a nice unit rate. They're doing the same proportion every time. So we're going to multiply by 4. 1 times 4 is 4. 2 times 4 is 8. So on the second bead of red, that means they've times 4 to make 8 green beads. When we've done 3 red beads, we times that by 4, and that tells me I've done 12 green beads. So 3 red, 12 green. So it's following the same pattern. So Y is 4 times the value of X, or I could say that red, going backwards, is 1/4. So now we want to write this equation. So what pattern were we following? What did we do every time? We multiplied by 4. What did we multiply by 4? Well, all of these numbers are represented by x. And when we do 4x's, that's going to equal y. So we just plug in those variables. We replace what did this here stood for x. What did we do to it? And it equals the second variable. So go ahead and complete task 2, and then come back when you are ready for task 3. Task 3 tells us that we can model real-world situations using an equation. The graph below shows the distance d in miles a car traveled over time in hours. So remember, this is the one going across is our x. They're using t for time or hours, but it's our x variable. This is our independent one. This is what they get to choose, is how much time they spent in the car. And then d, our distance, is our y variable. This is our dependent. So the miles they travel depends on the time they rode in the car. So this is our answer here. So whatever we do here gives us our answer of y. So let's take a look at this graph. So it looks like if they spent 1 hour in the car, they went 50 miles. So let's go ahead and list all of these ordered pairs here. So the first one is 1 hour, 50 miles. So see if you can finish listing the other 3 ordered pairs that are given here. So next we have over 2, and now they've gone 100 miles. Then we went, 3 hours is 150 miles. And then 4 hours is 200. So we always use that x across, then go up, is 200 here. So what kind of patterns are you noticing here? So some things I notice is every time I drive 1 hour, it takes me 50 miles, right? 1 hour, 50 miles. 1 more hour, 50 miles. 1 more hour, 50 miles. 1 more hour, 50 miles. You see how these triangles are all exactly the same? That's telling me that it's a constant rate. They're doing the same thing over and over. Same thing over and over. They're driving 1 hour, 50 miles. 1 hour, 50 miles. So this unit rate triangle can prove that it is a constant rate. So I know, right, every time it goes over 1, it goes up 50. Over 1, up 50. So let's write an equation for that. So, right, every time we have our time, we go 50 miles is our unit rate. 1 hour is 50 miles. And we'll multiply that by the time we choose to spend in the car. Will tell us the distance we want to spend, right? I have 1 hour is 50 miles. I want to see if I spend 2 hours in the car, 50 times 2 is 100. 2 hours, 100. So that fits my graph here. So I think the hardest part sometimes is deciding what is this number going to be? And I can see, right, every time we did 1, the unit is 50. If it helps you to write this out in a chart, 1 to 50, 2 to 100, write it out in a table, 3 to 150. Ask yourself, how did I get from X to Y? I had to times by 50. How did I get from 2 to 100? Times by 50. So every time, what am I doing? Timesing by 50 to the x, or in this case, the t for time, equals the y, in this case, is d for distance. So this number here, this constant, comes from this pattern. What are you doing to get from x to y? So go ahead and complete task 3. And that is everything for our lesson today. So you're going to do your check for understanding and homework today. If you need any more help with this, be sure to let me know and we can set up a time to meet together.